Hello everyone! Today, you will apply the distance formula in proving some geometric properties. First, let's recall the distance formula. The distance formula is d is equal to the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared, where d is the distance, x sub 1, y sub 1 is the coordinates of the first point, and x sub 2, y sub 2 is the coordinates of the second point. Now, let's have this first problem. Triangle ABC has coordinates A negative 3, 5, B 1, 5, and C 1, 1. Show the triangle ABC is an isosceles triangle. To prove the triangle ABC is an isosceles triangle, you have to show that two sides or exactly two sides of this triangle are congruent. To do this, we are going to find the distance between 2 points. Specifically, the distance between A and B and C, and A and C. So to find this distance, let's have it one by one. Let's start first in finding the distance between point A with coordinates negative 3, 5, and point B with coordinates 1, 5. So again, in finding the distance of these 2 points, you will use the formula. D is equal to the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. Since we are looking for the distance from point A to point B, we can change D by AB. So AB is equal to the square root of the quantity of x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. So to make it short, do not copy the right part of the formula. Instead, substitute all the values of x sub 1, x sub 2, y sub 1, and y sub 2 by the given values. So your x sub 1 here is negative 3, your y sub 1 is 5, your x sub 2 is 1, and your y sub 2 is 5. So let's substitute all the values. X sub 2 is 1. So we will put here 1 minus x sub 1 is negative 3. So let's put another open and close parenthesis to separate the two symbols, like the minus symbol and the negative symbol. Plus, your y sub 2 is 5, so we will put here 5, minus your y sub 1 is also 5, and copy squared. Now, let's simplify. AB is equal to the square root of, so as you can see, you have here minus negative. Negative minus or negative, open parenthesis, and another sign of negative, it is equal to positive because negative times negative is positive. So we will now write 1 plus 3 squared plus 5 minus 5 is 0. So we have 0 squared. Let's further simplify. AB is equal to the square root of 1 plus 3 is 4. So you have 4 squared plus 0 squared is 0. AB is equal to the square root of 4 squared is 16. So you don't have to add 0. Now, you can write your answer in this way. AB is equal to the square root of 16. However, square root of 16 is a perfect square. So we can simplify it into 4 because the square root of 16 is equal to 4. To get the square root of a perfect square number, you have to think of a number wherein if you multiply it by itself, the answer will be the radicand, or what's the number inside of the radical sign. Since 4 times 4 is equal to 16, therefore the square root of 16 is equal to 4. So we have here AB is equal to 4. So this is now the distance from point A to point B. So from point A to point B, you have 4 units. Okay, next, let's see what's the distance of point B from point C. So you have B. So the coordinates of B, 1, 5, and C is 1, 1. So your x sub 1 here is 1, your y sub 1 is 5, your x sub 2 is 1, and your y sub 2 is 1. So let's write the formula. Do not write D. Instead, write BC. BC is equal to the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. So let's substitute all the values. Your x sub 2 is 1, so you will write here 1, minus your x sub 1 is 1, so you will write here again 1 and squared. Plus your y sub 2 is another 1, minus your y sub 1 is 5. So you need to write here negative 5 and squared. So let's simplify. BC is equal to the square root of 1 minus 1 is 0 squared, plus 1 minus 5 is negative 4. So you have negative 4 squared. Again, let's further simplify. 0 squared is 0 plus negative 4 squared, or negative 4 times negative 4 is positive 16. So again, you have square root of 16. And I told you a while ago that we're going to simplify it into 4. So the distance from point B to point C is also 4 units. So this is also 4 units. And a while ago, you also know, or you also get the distance from point A to point B, which is also equal to 4. Now, you see that the two sides of this triangle ABC are congruent or equal. However, we still need to prove that the measure of side AC, or the distance from point A to C, is not also 4. Because if that happens, you don't have an isosceles triangle. Instead, you will have an equilateral triangle. So we need to prove that point A to point C has a distance that is not 4 units. Okay? So to do that, let's find the distance of A, negative 3, 5, and C, 1, 1. So your x sub 1 here is negative 3, your y sub 1 is 5, your x sub 2 is 1, and your y sub 2 is 1. So let's write AC is equal to the quantity of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And let's substitute all the values. Your x sub 2 is 1, so we will write here 1, minus your x sub 1 is negative 3. So again, we will put another open and close parenthesis to separate the two signs or the two symbols. Plus, your y sub 2 is 1, minus your y sub 1 is 5 squared. Okay, let's simplify. 1 minus negative 3 is 1 plus 3. So you have 1 plus 3 squared plus 1 minus 5 is negative 4. So you have negative 4 squared. AC is equal to the square root of 1 plus 3 is 4 squared, and negative 4 squared is equal to positive 16. But let's write again negative 4 squared for parallelism. So 4 squared is 16, and negative 4 squared is also 16. So AC is equal to 16 plus 16 is equal to 32. So the distance from point A to point C is equal to the square root of 32 units. However, we can still simplify the square root of 32 into AC is equal to the square root of 4. AC is equal to 4 square root of 2. So how does it happen? 32 is divisible by 16, right? So we have 16 times 2. And if you get the square root of 16, you have 4, and what remains inside of the radical sign is 2. So you have AC is equal to 4 the square root of 2 units. So going back again, we have AB equal to 4, BC equal to 4, and AC equal to 4 square root of 2. Since only two sides of the triangle are congruent, we can now conclude that triangle triangle ABC is an isosceles triangle. Again, since AB is equal to 4, BC is equal to 4, and AC is equal to 4 the square root of 2, only two sides of the triangle are congruent, and that are sides AB and side BC. So triangle ABC is an isosceles triangle. Okay, this time let's have another example. Let's have another type of figure. We have quadrilateral love. So quadrilateral love has coordinates L negative 3, 2, O 2, 2, V 5 negative 2, and E 0 negative 2. You're going to show that love is a rhombus. Take note that when we say rhombus, rhombus has four sides, and that four sides are all equal. Okay? So you have to prove that side LO is congruent to side OV and congruent to side VE, and again another side LE. Or in other words, you have to prove that all of the sides of this quadrilateral are congruent or equal. And that's how you are going to prove that quadrilateral love is a rhombus. So let's solve for the distance of each 2 points. So let's start with LO. So let's find the distance of this point. No, let's find the distance from point L to point O. So we have L negative 3, 2, and O we have 2, 2. So let's have LO equals the formula, the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. LO is equal to, so your x sub 1 here is negative 3, your y sub 1 is 2, x sub 2 is 2, and your y sub 2 is another 2. So your x sub 2 again is 2, so we will write here 2 minus the x sub 1 is negative 3. So again, we will write an open and close parenthesis to separate the two symbols. Plus y sub 2 is 2 minus y sub 1 is also 2 squared. So LO is equal to 2 plus 3 squared is 5 squared. Plus 2 minus 2 is 0, so you have 0 squared. LO is equal to the square root of 5 squared is 25 plus 0. So you have LO is equal to the square root of 25. So let's simplify square root of 25. What number that if you are going to multiply to itself is equal to 25? Very good. That is 5 because 5 times 5 is equal to 25. So the square root of 25 is equal to 5. Therefore, the distance from point L to point O is 5 units. So that 5 units will be our basis. Let's show or prove that this side OV is also 5, EV is also 5, and LE must be also 5 to prove that that quadrilateral love is a rhombus. So let's proceed. So we have now OV, OV. So your O is 2, 2, and your V is 5, negative 2. So your X sub 1 is 2, your Y sub 1 is 2, your X sub 2 is 5, and your Y sub 2 is negative 2. Let's use the formula. OV is equal to the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. So OV is equal to the square root of your x sub 2 is 5. So 5 minus x sub 1, 2. So we have 5 minus 2 squared plus your y sub 2 is negative 2 minus your y sub 1 is 2. So you have negative 2 minus 2 squared. OV is equal to the square root of 5 minus 2 is 3. So you have 3 squared plus negative 2 minus 2 is negative 4. So you have negative 4 squared. OV is equal to the square root of 3 squared. So you have 9 and negative 4 squared is 16. So OV is equal to 9 plus 16 is square root of, or the square root of 9 plus 16 is equal to the square root of 25. So OV is equal also to 5 units. So this point, point O to point V is also 5 units. And a while ago, you found out that LO is also 5 units. And if we will continue solving for the values of, or for the distance of E to B and the distance of L to E, you will also get that this is 5 and this is also 5. So with this, you can say that quadrilateral love is a rhombus because all of the sides of this quadrilateral are equal to one value, and that is 5 units. So I hope you learned from this lesson. So to see if you learned from this lesson, please get your paper or scratch paper, your ball pen, and as well as your notebook. So for your activity, you're going to answer the same problems. And take note that your solution or your answer must be written in your notebook in complete solution. So bye everyone. Thank you for watching and I hope you learned from this video.